Very good morning, friends. I welcome you all to my YouTube channel and myself, Dr. M.H. Annaya. And friends, in today's video, we are going to learn about the section of solids. And I have taken up a square pyramid for today's video. And the question for today's video reads like this: a square pyramid of base 40 mm and height 70 mm. So base is 40 mm and the height measured from the vertex to the center of the base is 70 mm, resting on its base on HP. Is cut by a section, friends, resting on HP on its base, such that the true shape of the trapezium is true shape is a trapezium. Friends, initially the placing of the object on HP plays a vital role. Here, friends, suppose if you keep this pyramid like this with all the base edges equally inclined to VP, then, friends, what happens? If you are cutting by a section plane which is normal to HP, is going to cut 1, 2, 3, 4, all the 4 slant edges of the pyramid. But that figure is not going to become a trapezium. It becomes something like a four-sided rectangle. It's not a trapezium, it's going to be a rhombus-like figure. Friends, so you have to place the object like this on HP such that one of the base edges of the solid is normal to VP or one of the base edges parallel to VP. So it is the same in case of a square pyramid. So place the pyramid on HP in this position, obtain the top view, a square with the center joint to all the diagonals, front view is going to be a triangle. Friends, now I am going to write down the top view of the pyramid first. So friends, this is the top view. Say it is a square and side measuring 40 mm. It is given in the question. So every side of the solid measures 40 mm. We will call this as ABCD. The corners of the base of the pyramid. Project lines from here and obtain the front view of the solid. So friends, the height is given to you, so you can obtain the front view. O dash the vertex, join that to all these corners. So you will have here A dash, B dash, C dash, D dash. Center is O comma O1 and this is O1 dash. The axis of the solid is perpendicular to HP. Now friends, he says it is cut by a section plane which is normal to VP such that the true shape is going to be a trapezium. That is, when the solid is cutting like this, it is going to cut all the 4 slant edges, namely O dash A dash, O dash B dash, O dash C dash and O dash D dash. All the 4 slant edges are going to be cut by the section plane. And he says the true shape you are going to get is going to be a trapezium. So a trapezium, a rectangle with 2 sides parallel to each other. There are 2 sides parallel in that. And he says one of the sides measures 30 mm. Suppose the section plane is cutting like this. Here one of the side of that should be 30 mm and the other side will be obviously smaller than 30. So friends, what we can do here is we can draw a line through the center and mark on this line that minimum, that is measurement 30 mm, 15 millimeter on both the sides. So that what happens, friends, this is 15 plus 15 is 30 and we extend a line from there. So it is cutting this OA at this point. Similarly, OB will be cut at the same distance from that corner. So this measurement is going to be 30 because 15 plus 15 is 30. Now friends, taking this as the reference, so I will just produce this line from here. It will cut the slant edges OA and OB, say at points 1 comma 2. I will write down. This is 1 comma 2. Say this is 1 and this is 2. 1, 2 represents one of the sides of the trapezium. Friends, the other data he says, and the distance between the parallel ends of the trapezium is 50 mm. Friends, suppose the other end is here. If you project a line from here, it will cut somewhere here. And this distance should be, is not given, we are required to find out that. And now he says the distance between them is 50 mm. So taking this as center and radius equal to 50 millimeter, I strike an arc. I join this line with this, and friend, this is going to be our section plane which we represent S and S. So it is cutting the slant edges OC and OD here. We will call it as 3 comma 4. So this is 1 to have written here. So from there you can write a vertical line and it is meeting here. This is 1, 2, this is 3 comma 4. I will show an arrow downwards because we have taken that point downward. And this distance, whatever you have marking here, is equal to 50 mm that is given in the question. So sometimes instead of giving this distance, they give you the dimensions of the other parallel end of the trapezium. Friends, we have got these 4 points, join them by straight lines. Friends, this is how those points of the trapezium look in the top view. Friends, here, this is the top view of the solid. And here we have to show all these by dark lines. And the complete view along with the section portion will give you the sectional top view STV, and this will give you the front view of the solid. And here friends, you have to darken this lower portion of the solid, and this is the front view which I have shown in dark lines. And friends, we have been asked to find out the true shape and also measure the inclination of the section plane with HP and VP. Friends, this is section plane, and if you just measure this angle, this will give you theta. Theta represents the inclination of the section plane with the HP, and this will give you the front view. And the true shape, he says, is a trapezium. Now friends, we have to obtain the true shape of the section. So friends, you know very well, the true shape of a section is the mirror image of the cut portion of the solid. That is, if you hold a mirror parallel to this SS somewhere here, if you hold a mirror, whatever the image you get for this portion, cut section, is called the true shape of the section. Friends, what do we do here? We write a line here parallel to this SS. This line is parallel to this at any convenient distance outside this solid front view. And from these points 1, 2 and point 3 and 4. So from these 2 points, namely 1, 2 and 3, 4, draw lines perpendicular to that. Now we have to obtain the true shape here. How to obtain, friends? For obtaining the true shape, we have to take the measurements of the points 1, 2, 3 and 4 from the XY line. Friends, 1 and 2 are here, they fall on this line. The distance of 1 from XY is this much. So this distance I am going to transfer here, and I call that point as 1. On the same line lies this point 2. So I will take a measurement from here to here, the distance of 2, and mark somewhere here. So I will call this as distance 2 or the point 2. Friends, very obviously, this 1 to 2 is equal to 15 plus 15, that is equal to 30. So the distance is going to be 30 millimeter. Friends, on the same lines, on this line drawn perpendicular to this, note down the distance of 3 and 4. 3 from here to here is that 3. 1, 2, 3. And the last point 4 is at the same distance as it, that is 4 you will take some. So friends, we have taken all the 4 points, join these 1, 2, 3, 4 by straight lines. So this is 1, 2 by a dark line, then 3, 4 dark line, then we have this 2 to 3 by a dark line, and this also by a dark line. Friends, after obtaining the 4 points and join them, had that area or section that area. Friends, this figure will give you true shape of section, and this is a trapezium. And friends, we have found out what is the angle the section plane is making with HP, and also we are asked to determine the measurement of side 3 and 4. One side is given to us, the distance between these two is given as 50 mm, which I have already marked here. This 50 mm is same as this 50, and friends, you can just keep a scale and see what this measurement is. So this will give you the distance of the parallel end of the trapezium. So you can keep a scale here and find out the measurements. Friends, I hope the presentation was useful to you. Please go through the complete video, and at the end of the video, if you like it, do share this information with all your friends. Have a nice day. Thank you very much.